Okay, good evening, everyone. So today we'll be talking about database, in particular the NoSQL databases. What are NoSQL databases? How do they work? And the specific database of DynamoDB. I believe whatever I have done yesterday inside CloudFront, inside S3 bucket, and inside Route 53, you would have done all of those things. It's pretty important because that's what they are going to ask you in the interviews. Okay, so let's get started.
Recording in progress.
First thing first, we'll be talking about the service in general, which is known as a database. A database, in short, is nothing but a specific software that will do some amount of data manipulation for you. Now, data manipulation can be done by Excel also. The difference over here is that if you have millions and millions of records which are getting processed per second, and you have to go and save the data somewhere and you have to process that data, in that case, you need help of a specialized software which is known as a database. There are two types of databases. One is a SQL database and one is a NoSQL database. Earlier, if you go to the previous video recordings, you will see that I used to invest a lot of time explaining about SQL and NoSQL. Now, honestly, it doesn't matter also because no one will ask you what is SQL, what is NoSQL. Just one basic difference, keep in mind that a SQL database will have a specific structure of the table. So what happens is whatever specific data you want to keep, you will be storing it inside something known as a table. The table will have a specific structure. If the structure remains as it is, and if in case you want to go and save the data in a different format, if that cannot happen, it is known as SQL. So when so that SQL itself stands for structured query language. So you have a database, you want to save some data, you want to go and query that specific database, it is known as SQL, structured query language. NoSQL is no and then SQL. So I don't have any structured query language. So if the structure is pretty rigid, you cannot evaluate it a lot. Whatever data is there has to be in that format only. It is known as SQL. Otherwise, it is known as a NoSQL database. Next part, NoSQL databases are of various types. Again, you might want to go and read about it, key value, column, family, graph, and document. Now, if you are a developer, then you have to go and worry about it. If you are not a developer, then it doesn't matter because these decisions are taken by the developers themselves that what database they actually want to go for, either a key value array or a column value or a graph or a document DB. Or if you are a solution architect at the application level, then you go and make the decisions. At DevOps level, your job simply is that the developers will say, I want to go and use this specific database. You just have to go and manage that. That was the first part. Now it is even more interesting because now we have the concept of the serverless databases. For that reason, you might have seen earlier there were a lot many things where people used to talk about DBAs, database administrators. Now you suddenly might have seen that DBAs are nowhere to be found. There is no meaning as it is for DBAs. Simple reason for that is whatever the database is there, it is being managed by the cloud, and if it is managed by cloud, it is managed by people like you. The only difference that DBAs would have done would be how to go and optimize the performance of a database. That is the first thing. Now consider it like this. I want to know that I want to go and increase the performance of my database. So how will you know and what are the factors for it? So if I have a table, I have multiple records, I want to query the records, database administrator or the DBAs, how we will call them now, will tell them that, see, this table is performing slow because when you are going and fetching any data from the table, it is actually taking a lot much time. This time is known as latency. Latency is a word that you are going to use in your entire journey of your specific career in DevOps or cloud. For instance, latency in simple terms, simple means the delay. For instance, you ask me a question and I say, share your screen. We will do it now itself. You ask me a question, I give the reply. So latency is almost few milliseconds over there. Another option is you ask me a question and I'll say, okay, do a thing, write it in the group and I will get back to you. And I reply back after 2 days with the possible solution. So in one case, the latency is few milliseconds, and in the other case, the latency is few days. Which is better? You know the answer yourself. So low latencies in general is always better because that means the lag or the delay is not there. Now coming back to a database. I go and ask my database about a specific value or about a specific record. For instance, I go and say, I want to know all the employees, those who are earning more than 1 lakh a month, who are based out of Bangalore, and who have been in the company for more than 1 year. Give me a list. This might take, let's say, 100 milliseconds in processing. That is one way. Second is I can go and ask the same information, and that information might be fetched in few, like let's say 10 seconds or something. So which one do you need or which one is better for you? You have to answer yourself. Lower the latency, better is the actual response time, or in short, better is the actual database or that specific application. So that is one way basically on knowing that how the specific latency. So lower latencies are always better. Lower latencies are always preferred also in our case. Next part, basically, if you go with a specific database and like taking example, I go and fetch some data from the specific database. Like I'll just give you a quick example of it. I was while
Recording stopped.
I was actually talking to you, I was doing this. So if you have a look, these are the actual applications which we are using right now. I'll make it last 24 hours. Okay, and just refresh the page once. So in my case over here, you can go and see that this is where the applications are being used at the moment. Let it come. Response time will take a lot much time because I have done 24 hours. Let me make it less, maybe last 3 hours. Refresh. So this is in general how the graphs are calculated, and based on this itself, you can understand how the performance is there. So if you see in my case, the latency maximum is going up to 16 milliseconds. If you see 16 is the maximum. If you see over here, most of the time the latency is between 0 millisecond to 0.3 milliseconds. Any of these APIs, if they are getting called now, if you click over here, it will show you the latency is 0.0039 milliseconds. Or if you go over here, it is taking 0.02 milliseconds. This is of last 3 hours. Let's make it of last 12 hours and see yourself. This is how we calculate this. They are going to ask you in the interview also. This thing that I am telling you is something known as APM, Application Performance Monitoring. This is the last thing that actually means if you go to that level, and when you go to that level, you will be talking about APM, Application Monitoring Tool. So my servers are actually, let me go and duplicate the tab and you will understand it better. So let's go here and let's say these. So not these actually. Please avoid taking a screenshot of this. So over here, if you see, these are the specific requests which I am getting right now. So these are the, I believe, the biometric devices. So these are the biometric devices out of which it is actually sending me the data right now at what time? 9:42 p.m. In my case, everything is in IST only. So these are the ones biometric devices right now are being sent. If you want to see, these are the specific notifications. These ones are from this specific company, which means B2B business they are doing. And these specific requests are there. And these are the specific errors. These are the maximum time which are taking. These are the specific requests which are actually coming to me. These are the specific error message. In 24 hours, I got these many error message. In 10 days, I got these many. In 2 weeks, I got these many. These are the specific headers which are trying to hit me, and these are the specific IDs from which I am getting the specific response. So this thing is known as APM, application performance monitoring. The interesting thing here is that you want to see something like this. So in my case, you see very boundary condition somewhere over here is taking approximately 600 milliseconds. Now, if you pay attention to this graph, you will understand that most of the requests are being handled in this region, 0.25 milliseconds, which is a very beautiful number, which means that my load balancer is getting the request, load balancer is sending the data to the backend machine is sending it to the database is performing the request, it is sending it back to the backend machine is nothing but Kubernetes in my case. So from my route 53 to my DNS to my load balancer to my pod to my database it does whatever response it is to be fetched, it goes back to my backend, which processes the application, goes back to my ingress, or in this case, egress, which is the load balancer back to route 53, and back to the actual customer. And all of that is happening in approximately 0.25 milliseconds. 1 millisecond is 1 upon 1000. 0.25, you can go and calculate it yourself only. So it is taking very less time in processing the application. So if you start to see something like this, it means everything is good. What I've also done is over here, actually, I have created this sort of a dashboard. Like if it becomes red, it means I am getting these many requests per minute. So in 1 minute, I am getting 1011 requests. Green one will always be less. I am getting 400 requests, 200 requests, 100 requests, and so on. So if you create a chart or something like this, that basically will tell you that how your application is performing, A, and B, how are your specific applications responding. Like looking at this, you understand from here to here, I did not get any request in the night. My request actually will start somewhere from 8 a.m., will go all the way up to 9 p.m., and after 9 p.m., it's almost green. And then again at 7 a.m., and so on, it will proceed. Maximum things will happen at 1 p.m. I basically work into edtech industry. So inside edtech at 1 p.m. approximately, most of the things are happening. Lunchtime is happening, teachers are updating the results and so on. So over here, you would start to see red. Over here also you would see, because attendance, biometric, smart cameras, everything is getting processed. So this is latency. Now, when I start to see red things over here, if by mistake, like I am saying 24 hours, let's make it maybe last 7 days, will take a lot of time. If I start to see no request like going into 10 seconds and 11 seconds, latency is taking 10 seconds, latency is taking let's say 5 seconds, then I start to panic that okay, something is not behaving the way it should be. Okay, so lower latency is always better. Now, these things people will actually ask me that Ankit, what are the actual latency values? And I have actually shown you in production. Okay, so maximum that I ever hit also is 1.02 seconds. That too, I would go only for these ones. So 1, 2, 3, 4, 5 requests. And that too is only happening when people are actually opening the report card of their specific students. And somewhere over here, when I am going and looking at my specific application and the dashboard. So this chart itself is telling me that the latency is less. Okay. Apart from that, we have created more things also, like the graphs from where in the world it is getting used and all those things. So those things are also there. Now, if you go into APM things at that point of time, we will talk more about it. We'll actually see it more. So we'll talk about it at that point of time. Okay. So let it be fine. So let's go back and resume.
Recording in progress.
So the concept here is like whatever specific applications we are actually using, whatever specific database is there, it should always take as less time as possible. In my case, if you see, it is taking 0.02 milliseconds. That includes the backend, that includes the database, everything. So ideally, latency should always be in few milliseconds. Best case, single digit milliseconds or even less. Worst case, in two-digit milliseconds. By that I mean 10 to 99 milliseconds. It should not go in seconds. NoSQL database is very good in that. You go add any data inside the NoSQL database, and that specific database will give you the response very fast. Why? One reason is it is NoSQL. Second reason is it has some concepts like sharding, something like vertical scaling. What do those things means? Let's talk about it very quickly. So I have one server, it is taking 10 seconds. If I go and take four servers, it will take 2.5 seconds, right? Because I have four servers now. If I take 10 servers, it will take only 1 second to process the information. If I take 20 servers, it will take 0.5 seconds to process the information. So in short, if I go and increase the number of the servers, it is actually taking less time in processing. That is a very general thing. I don't have to explain that to you. That thing is known as horizontal scaling. Why to have one server when I can have 10 servers? Why to have 10 servers when I can have 20 servers? NoSQL can actually go and do it very easily. Second thing is something known as sharding concept. Okay, just know about it once. If you know, it is good. If not, that is also fine. The concept is whenever I have to go to a database, let's say I have three machines. Will all the three machines keep the data, or one machine will keep one third data, second will keep the next one third data, third will keep next one third data? If you go and ask me for any specific information, data is equally distributed. In that case, I will actually go to that machine. This concept is known as sharding. So sharding is used a lot in MongoDB actually. So what happens is data is actually distributed across multiple machines. Distributed, okay, not replicated. Replicated is different. Replicated means I will also have, you will also have the same things. But then people say that why are you replicating? If two people are having the same data, it doesn't make any sense. Rather go and distribute the data. I will have one half of the data, you will have next half of the data. That is known as replication, or in this case, it is known as sharding over here. Why are NoSQL databases so fast? Because one, they will do horizontal scaling. In short, why to have one machine when I can have 10 machine? And B, because they will have the concept of sharding. Why you will have all the data when I can actually go and distribute the data across multiple shards. Now, till now, whatever I told you, if you understood, good. If you did not understand, that's also fine, because DynamoDB is known as NoSQL serverless database. In short, why do you have to worry? Database is taking 1 second or 10 seconds. Do I need to have one server or 10 server or 100 server? Why do you have to worry that how is the performance of my database going to be better? Okay, which is better, SQL or NoSQL? See, I work only in NoSQL. When I started working, I started with Apache Cassandra. Means I am a contributor of that anyhow. So I started with Apache Cassandra and MongoDB. So I would say NoSQL is better. But right now, if you are listening to me, that's because you have paid the fees of the class. You have paid the fees of the class means some UPI transaction or some card transaction has happened, which means somehow you have gone to the financial institutions, and financial institutions are only working on SQL database only. They are not using NoSQL database for the simple reason each of the database has something known as ACID property: atomicity, consistency, isolation, and durability. Those of you who have done computer science would have read about it. Those of you who have not done, you might want to go and just read about these four terms. What does it mean? Atomicity, consistency, isolation, and durability. Just normal theoretical things. Last in the interview, anyone asked, it was almost 2 years back, so no one is interested in asking this. But in case I take the interviews, I will say that which is better, SQL or NoSQL, and the person will give a normal answer, and that's also fine. But if you go and use the term as acid property, that actually creates more impact. You ask me, I will say NoSQL for the simple reason I have been working on it. You ask any financial institution, they would say SQL databases are better, because if you think about it, in NoSQL database, you are working like I'll give you example, Uber, Netflix, they are all working on NoSQL. Very fast, right? Uber, you book something, location is getting updated immediately, everything is NoSQL. Banks are using SQL. You go, you click on the login button today, login will actually happen tomorrow. You go and click on submit button today, actual result will happen tomorrow. You click on it two times, it will fail, it will log you out, right? Because that is SQL database. It is good in a way because it follows these things: atomicity, consistency, isolation, and durability. Means it is good because if I do a transaction, the transaction is done. It is not like I did a transaction of 100 rupees and you say that, oh, 100 rupees, because it is no SQL, it is not there. So banks are still using ACID properties for that reason, SQL. Others, if privacy and those things are not that much of a question, means I won't say privacy, rather, let's say if ACID properties are not that much a question, in that case, you will go with your NoSQL database. So banks or financial institutions are still using SQL database. Now, just I will just digress from it. Means I will just show you one picture because you asked me this. I'll just show you one. If you understand, good. If not, we will move it after that. Okay. So what happens is, no, like taking example of any of the database. Also, what I'm going to tell you over here means no one will actually go and talk about the architecture of a database. So if you understand it, good. If not, there is no way also you can understand this. Fine. So let's talk about it. So what happens is, like, let's say I am in a bank and I go and take 100 rupees out of my account. So it goes over here. ATM will say, go, Ankit has withdrawn 100 rupees. So Ankit account is, let's say, 1000, 1000, and 1000. Obviously, Ankit account is 1000. All three of them have 1000, 1000, 1000. Next part. Ankit withdraws 100 rupees. So 100 rupees goes over here. It says that, okay, it goes over here. Please update Ankit to minus 100. It says, okay, I am 900. This is down. This is down. So now this says 900. This still says 1000 because it was not updated. This still says 1000 because it was not updated. Next time, again withdraw 100 rupees, or next time I simply go and say that what is the transaction status or what is my account balance right now. It goes over here and it says that's the account balance of Ankit is 900. It goes to this machine. Now this machine is up. This machine is up. It goes to this machine. It says that, oh, my last value Ankit is 1000. My last value Ankit is 1000. So over here, what will happen? First thing, if one time it goes, it will show you 900. Second time it goes, it will show you 1000. Third time it goes, it will show you 1000. Fourth time it goes, it will show you 900. These things we cannot do because I have to always give you one answer only. So how do I give you one answer? In that case comes the concept of democracy over here. In short, what happens is I will go and say that, hey, Ankit account is how much? It will say 900, it will say 1000, it will say 1000. Democracy wins. Over here, it becomes 1000. Reply goes back and you say 1000 rupees over here. One more thing also happens, by the way, because these two people are saying 1000, they will go and force this machine also to make the value as 1000. So what will happen? This and this is 1000. This will say, I know Ankit's value is 900. These two will say, sorry, democracy wins. You also are now 1000. So what happens? Even though I withdrew 100 rupees from my account, in that case, still my response is 1000. This will happen only in very specific cases if both of them go down. So how to fix it in that case? Very easy. Whenever I go over here, no, I say, let's go back 2 minutes back into the discussion. Ankit's balance was 1000 rupees, 100 rupees withdrew. Over here it goes to 100. I get over here it says update 900, update 900, update 900. This says updated. You get a message 100 rupees debited from your account. Fair enough. It says hey update, hey update. It has sent a request. For 10 seconds, it doesn't get any response only. Remember, because three machines are over here, first now when doing a write itself, I will ensure that two machines or majority is saying 900. So this says, okay, done. No response. No response. It says done. You get a SMS ting 100 rupees debited from your account. Second, It is waiting and waiting. It waits for 10 seconds. It doesn't get a response. So this Mongoose or Mongod tells this that, see, I sent a request to B and C. I did not get any response. It seems they are not active at the moment. Do a thing, whatever transaction you did, roll back. So whatever transaction was done of 100 rupees, where it became 900, that again becomes 1000. So this also becomes 1000. Ting, you get another message that, hey, your account has been credited with 100 rupees. Now, these are not magical things. You might have seen these also. But remember, you will not see it now. Earlier, you might have seen all this drama happening because ATM internet connection was not very stable. These two servers were not responding. Now you will not see these. So you go to ATM, you take out 100 rupees, you get a message that 100 rupees is there. Suddenly you get a message that your account balance is not updated also. You are very happy that, oh, 100 rupees also came out, account balance also not updated. Very good. You go the next day, by that time rollback has happened. You go and see what is the response, minus 100 happened. Okay. So these things used to happen earlier. What happened was banks actually wanted to implement NoSQL a lot. All of this drama actually forced them not to do it. They went back to our specific SQL databases, which are the ACID properties. Now, by the way, what I was talking to you right now was isolation and atomicity. Either it happens or it doesn't happen. Coming back, what is better? Ask me again, I will say NoSQL is better because yes, MongoDB also has sort of ACID properties now. Not exactly, but sort of ACID properties. If you go and see, it says that, okay, I do have the ACID properties in MongoDB right now, and not very rich. I work on MongoDB every day. I can tell you it is not that very rich. In reality, we have to go and handle it programmatically only. We use Kafka. So any message that actually comes to us goes to my queue. And from there, actually, we go and write it inside MongoDB. And same thing happens for Apache Cassandra. I work on two MongoDB Cassandra. It has to be handled at the application. So coming back, banks anyhow will still be using SQL because in banks, what happens? So now what happens is banks, they don't have all this drama, three machines, four machine. No, bank will just have one SQL server. Data goes inside the SQL server or it doesn't go. I'll show you over here. Let's take this. Data is there. This is a SQL. It either goes or it doesn't go. That's it. So you say 100 rupees gone. If it responds back that yes, 100 rupees gone, it becomes 900. If after 10 seconds it doesn't respond back, it will go and say not debited. So banks are very safe. They go with SQL database only. Okay, so that's about the SQL and NoSQL. So which one is better? You have an answer. If you want to wait for not much time, SQL database. Don't have patience, NoSQL database. I work with NoSQL a lot. Means I work actually only with NoSQL. So I can tell you anything at application level. If I have to do, actually I will have to do it programmatically only. Databases does not support ACID properties. Any which ways, the reason why we are here is because we want to talk about DynamoDB. Now, again, if you understood what I told you, good. If you did not understand, even better. Because you don't have to understand all of these things. Whether you are one server or 10 server, whether you are sharding the database, whether you have democracy or not, whether you are using good volumes or not, it doesn't bother me. What simply bothers me is I am saying that, see, I would be doing 10 reads and 10 writes per second maximum. Give me the capacity, give me the database, or create the specific SQL database for me. Okay, whether in the backend you are creating 10 servers or 20 servers or 1000 servers or 10,000 server, it does not bother me. I am giving you the amount to do this job. Please do the job for me, and that's pretty much it. That is example of something known as a serverless databases. 2 years back, I would have told you serverless databases are what the industry is using. Now it doesn't matter because the industry is actually working on these specific databases only. First option is MongoDB Cloud, where you go and work on a serverless database. You don't have to worry. It is fully managed cloud database. Where the data is going, how it is going, how many servers are there, sharding is happening, replication is happening, backups are taking place, updates are happening, upgrades are happening, whatever. I don't care about it. I have given you the amount. Ensure I am getting these many reads and these many writes over here. Same thing happens with Mongo, with Astra, which is Apache Cassandra. Now it has become even more interesting with the advent of AI. The thing is, first of all, AI itself people don't understand. Second thing, in means this all works on vectors. Okay, so if I mean, say anyhow, if you're in my class, we will be talking about AI and vectors, how it is there. So let me just show you one over here. So anything inside AI is all because of this is bad, but means go and take any of documentation. Anything in AI is all because of vectors simply. Okay. In means it is like the most basic unit of machine learning. In short, vectors will tell you the direction. You just have to go and train your model in that direction in very easy. Okay, whenever you talk about neural learning, neural hashing, there we talk about vectors simply. The interesting thing is databases now obviously if AI is learning, it has to save the data somewhere, it has to save the data somewhere, it has to save it inside the database, and that database SQL cannot do it because SQL is very slow. So for that reason vectors are used in NoSQL. Same thing over here also, and if you go with vector in MongoDB, same thing you will find in MongoDB also. This thing is very new. I will talk about it in my class of AI class, but right now, which is better? You ask anyone who is working in machine learning, we will always say NoSQL because it is not like I train my model today on the database response you are giving me tomorrow. At that very moment, things have to happen. And machine learning now, even if some loss happens, if it happens, it happens. It's fine. Machine learning loss anyhow will happen. I will optimize it. So for that reason, we use NoSQL a lot, and especially in vectors, we use a lot. Vectors managing it locally will become a problem for you because you don't have those many resources. For that reason, you would go to cloud databases. Two options you have, either you go with MongoDB or you go with Astra, which is Apache Cassandra. So now databases are serverless only. DynamoDB doesn't support vector, but we have to do it, so we are talking about it. So coming back, say a serverless database simply means you don't have to worry how many servers and whatever resources. You tell me what you need, I will give you those specific capacity resources to manage that specific database. And that's pretty much it. You go over here and you create a table. But because it is serverless database, you just have to worry about one key, which is the primary key, which is the unique thing. Like I create something as a employee and I say ID is my unique key or primary key and I click on create table. Done. Where it is created, how it is created, what is in the backend, updates will happen, upgrades will happen, downtime will be there. No. 5 reads and 5 writes I will give you every second. You want more? Uh, refresh and click. You want more? Go to additional setting, click on edit over here and go and tell me how many reads and writes you need. You say, I do not know, AWS, you decide how many reads and writes. Fair enough, go and make it on demand over here. If you do that, in short, it will automatically scale up and it will automatically scale down. You do not have to worry about what is happening in the background. That is NoSQL database. Few other things you want to go and add a index. Now, index is interesting because I was talking about why the DBAs are no more into action or jobs you are not going to find. See, what is the job of a database? It will save some data. And if you need the data, it will actually go and send back that specific response or data to you. One of you has the name of extra things actually. So can you just change your name to your actual name or leave the class? This is not nursery class where you will go and put some fancy names. Rather, I think you should join the class tomorrow. Fine. So if you're not with your actual name, it's better not to take the class. This is not some natak going on that you will come with a fancy name and sit in the class because the movie is going on. Don't want to join? Do not join. Okay, any which ways, going back. So, what is the concept of a database? A database concept simply is you will add some data inside the database. Whenever you want to get or fetch that information, I will give that response to you. That's it at a very high level. You will add some information to me. I will give that information to you. For instance, you go and give me the latitude and the longitude of a specific person, and I will go and tell you that where that person was last, what was the maximum time he spent, how is that specific person actually responding, and everything I'll tell you. So database simple property is you give me some data, and when you need the data, I will give that to you. Now, if it is very complex, I might take more time in processing that specific data or processing that specific response. DBS will simply go and tell you that this is taking more time. But remember, I showed you the graphs, right? Just by looking at that, also, you can know that which API is erroring out or which API is taking more time. If you know the name of the API, you also know name of the table which is taking more time. Table anyhow is saved inside my cloud, which is AWS or Azure or GCP, whatever it is. If the table or the database is inside the cloud, I can go and ask my cloud also that, hey, cloud, which information of which table is taking more time? And it will tell me. These things can be known by multiple names. First is the queue size. Queue size very easy to understand. IRCTC at 10 a.m. or 11 a.m., whenever the booking starts, at that point of time, the queue size is very high, like 10,000, 20,000, right? That is one thing. Second thing is latency. People are going and requesting data from my specific table, and response I am not getting, latency is high. For that reason, I would go and say latency is. Now, because table also is inside my cloud, log also is inside my cloud. For me, for the cloud, it is very easy to tell you this table is taking more time. And why is it taking more time? This specific query is taking more time. And this specific query is taking time. Yes, because this specific query, when you are trying to run, it is taking more time. In that case, you can directly go and see what that query is actually doing in the background. One. Second, you can go and optimize it. Optimizing you will do via the concept known as indexing. Okay, so again, go and read about indexing and database. In short, it will tell you how the performance of your table will be better. Again, this is not a database class, so I won't go much into it. But if I have to tell you in 30 seconds, index simply keeps the key about a record inside a separate table. Did not understand? Think about it like this. You want to go and find out a specific chapter. Your book is of 1000 pages. You want to go and find out one specific chapter. First option is go and start looking. Page number one, no. Page number two, no. Page number three, no. Page number four, no. And up to 1000, it will take 1000 seconds. Or rather, you have an index in the beginning, right? Where it will say if this chapter, directly go to page number 823. You simply have to go and ask the index that, hey, where is this specific chapter? It will tell you, and you directly navigate to that. That is indexing. And that is exactly what a database also is. Now, if you go and have a look at the image, no, it will tell you this is the index. This is straight away pointing to this record. This is pointing here and here. So instead of going to all this big table, rather you will go to the index, and index will point you to exactly that specific record. In short, you go and add an index, the performance of the table will be better. However, you go and put indexing only everywhere. Your book is of 1000 pages. In that 1000 pages is index only. That is also a problem. Means index should be concise, right? 3 pages, 5 pages is fine. Index itself is 1000 page. Book is also 1000 page. Then there is no point also. So index, when you keep, no, you have to keep a balance. More indexing is also bad because now all the time will go in searching the index also. Less index is also bad because in that case, search will happen very slow. So it depends on how you are doing it. So that's the concept of indexing. Now coming back to my database. If I go to my monitor and my performance, now you see this CloudWatch, if you go and turn it on, this done. It will automatically tell you which table, which record, which query is taking more time. It will automatically tell you if you go and add this specific index on this specific table, the performance of your database or the performance of your table will be better. That's it. You see over here, most accessed, most throttle. Most access is good for me. Throttled, it is not happening. So you just have to go and add that index. It will tell you that this specific key ID people are searching more, name people are searching more, salary people are searching more. In your world, once you see it over here, you just have to go to index, click on create index and say that name I am adding as a index, and that's it. Now the performance will be better. Coming back, why the DBAs are not needed now? Because everything is told to me by the database itself, by the cloud itself. So why will I actually go and need a database, or I would need a DBA when cloud itself is telling me? For that reason, DBAs are not used also now. Second thing is, you guys will be doing the job of cloud database architect, and in reality, you will not be doing anything at all, because in reality, whatever database is there, cloud itself is going to tell you how to work and how to optimize the specific database. That's about my specific NoSQL database of DynamoDB. We'll very quickly go and talk about few things, like if you want to go and add anything inside the table, very easy. Click on create item, add, like I am saying, ID is 1. And let's say name over here is Ankit. I click on create item. You want to add one more thing, click on create item, ID is 2, and let's say name is Bharat, and let's say city is Riga, and let's say salary, which is a number. Salary is, let's give him 100,000, and maybe currency. He is earning in euros. Create item. Done. So you see, first record over here had only name and ID. Second has name, ID, city, currency, salary. Third can have even different. That is NoSQL. It doesn't matter only. Whatever you want to keep in the table, you can go and keep it as it is. You want to go and search for anything, you can go click on action, or you can go over here inside the query and you can go and search for that I want to go and search for this specific thing, like where ID matches 1 or where let's say ID matches 2. You don't want that, you can go and search for a specific attribute also, that where name matches whatever you are giving, like name matches Ankit and so on. So that will also give you the response. So with ID equal to 2 where the name is there. So depends on how you are doing it. So that's about the table. Now I can tell you how to add the data, how to remove the data, but in reality, millions of transactions are happening. Will you go and do it manually from here? No, this all will happen from the SDK, from the program. So programmatically, you should know how it is doing that. We will do inside our Lambda functions. Right now, just know that, okay, I can have a table. I can go and add whatever data is inside the table. I can go and do that. Right now, this table is in North Virginia. I want to go and add one more region. Why? If North Virginia is down, what will happen? So you click on create replica over here and say that the same table I also want to go and create it in Mumbai. Now, those of you who were in the previous class, in the end, when I showed you my problem, if you remember, my data was in Mumbai. I replicated it to Sydney. That is the easiest way, actually. Okay. So, in that case, now it is paper request or auto scale. What it is simply saying is you want to go and read and write the data. When you want to read and write, you are saying maximum should be 5 only. Then, how will I do? Go and make it on demand. Save changes. So now whatever replication has to happen will happen at the normal speed. Whatever AWS thinks has to be the speed. This and create replica. And that's it. So now what will happen is whatever the still in use. Fine. Let it happen. We'll click on create replica after that. So whatever table is inside North Virginia, the same table automatically will come inside the region of Mumbai also. So tomorrow, if Mumbai or let's say North Virginia is down, no worries. Mumbai is still up and running. My table in Mumbai would still be there and the data would automatically be replicated over there. I think it is still updating, is it? Okay, let's go one more time. Global table, create. It is being updated. That's why. Fine, let it be. We'll come back to it. Next is backups. You want to go and take a backup. You can always go click on create backup, and that's it. Go and click on create backup and tell create backup, and that's it. A backup will be created. Now, this is known as on-demand backup. Whenever you want to create, you create. Whenever you don't want to create, you obviously don't do it. If you want to go and create multiple, go and click on it multiple times. It will create that. Another option is something known as a PIT, or point in time recovery. Now, backups you are taking, will you actually go and do it manually multiple times? If you want to do it, you can do it. But ideally, it doesn't happen like that. Rather, you go for PITR, or point in time recovery. What happens is you don't have to worry. Just go click on enable, and that's it. Now, whatever backup you need, AWS is automatically creating. If something goes wrong, AWS will automatically roll back. You don't have to worry. The only tragedy, it will keep the backup for last 35 days only. Now you need more than 35 days. No one is stopping you from going and creating a backup, right? You can go and always create on-demand backup. For last 35 days, it is creating a backup every second. If at all something goes wrong, you can click on restore, and you can go and tell the time at what specific time you want to go and create the backup at, and the backup will be created, or the table will be restored at that specific time. And how much time it will take? Earlier, these things used to happen fast. Now more people are using it, has become slow only. Any which ways, next is export and stream. Like when we were talking about our AWS S3 itself, I told you anything that you do will always end up inside S3 only, right? Same thing here. You have your table, you want to go and export it to S3, you can always go and export it to whatever table is there, and you can export it. And by that same logic, the moment you have exported it, you can always go and import the data from the S3 also. So assuming I have my table, I export it inside S3 bucket in account one. S3 bucket account one replication happens in account two via replication. Once it is over there, I can always go and import the data from S3 to my DynamoDB table. So that is also one of the option. And everything is done. Only permission is there that for that we'll have to go to IAM. Okay, so once we are inside IAM, then you understand it better. So that's about my DynamoDB. In short, a NoSQL database where automatically whatever is the capacity you only go and create. The rest, what the data is, cannot delete also because we are updating it. Fine, by tomorrow it will be done. So we'll go and delete it, and I'll show you global table also then. So in short, you create a table, whatever is the capacity, how much it is being used, or who are using it, what is the capacity. You don't have to worry how many servers, encryption, decryption, updates, upgrades, management, user access. Don't worry. Just tell me how many reads or writes you need, and I will automatically go and create the table for you. That is a DynamoDB table for you. Tomorrow, we would talk about other databases also, like DocumentDB, Apache Cassandra, Amazon Key Spaces, and RDS or relational databases. Any questions if you have now, you can ask.
I have one question. So,
Recording stopped.
So you were talking about the sharding, right? Is it
Right.
similar to the master slave DB
Uh,
kind of architecture?
See, in master slave, master will not save the data, right?
Yeah.
Sharding everyone saves.
Okay.
Okay, so sort of means only master saving, that is the only difference. Rest all is same. Yes.
Okay.
Okay. Also, in master saved, now you have asked me, so unfortunately, I will have to tell more. Especially in case of Apache Cassandra over here. This one, what happens is no applications are interacting with all of them. So this is actual sharding. Data goes across six of them. But what is happening also, data is being kept across all of them. If one goes down, the backup is there and it is automatically, it's like, think about it like this. Apache Cassandra. Now, Those of you who want to leave, please leave. This will be pretty advanced actually. Okay, what I'm going to tell you. Now, take this example. Multi-data center in Apache Cassandra. Right now, though, we are just talking about one. Four machines are there. Okay. What if we go with multiple of them? Five are over here, five over here. Now, how will sharding happen? This is Zamunda is not a place. Consider it like America and Asia. Okay. So America database is like Google Maps actually behaves like this only. So whenever you go and update anything in Google Maps, no, what happens is it will show you over here, but anyone in US, if they try to see, it will take 24 hours. Why? In Google Maps in India, you have gone and updated one node, which is in Bangalore over here. Bangalore eventually will update all of them. So sharding is there, yes, but eventually the data has to be evenly replicated across all of them. So that is one. Also, when you go with multiple node, now we were talking about master slave. When multiple node are there, then who is the master and who is the slave in this case? So we'll say no master and no slave. No, that is not the case. One of them automatically becomes the master. And once it becomes the master, then replication happens across all of them. Now, master slave, if I say it is master slave, then that is wrong, because if this goes down, it means this data is gone. But no, inside the next DC, the data is still kept. If I say it is not master slave, then that is also wrong. If there is no master and no slave, then who is telling the where the data has to be kept? So it is combination of both actually. No SQL especially. Okay. You might be confused, but you asked me a question, so I have to tell the answer. Okay. Answer is both. Combination of both actually. Fine.
And this is Venu.
Yeah. Yeah. Ask.
Yeah, actually, I'm new to this database and also, which one would be better to learn?
NoSQL.
No,
100%. Apache Cassandra, in fact.
sure. Thank you.
Because AI is all Apache Cassandra only. Because like I showed you know over here, multi data center, this actually works with what we do is like I have in AWS also, GCP also, Azure also. So it is multi-region, multi-cloud infrastructure that only Apache Cassandra can do, and sort of MongoDB can also do. But best is Apache Cassandra if you can do, and certification of Cassandra is also very easy if you do it.
Thank you.
What are the
Yeah, Shivam.
what are the services that AWS provide for SQL?
Sorry, what are the
AWS services for SQL.
for what?
I mean, what are the services that AWS, like how you have DynamoDB for NoSQL, right? So
Document DB, no? We did it, no, in your class. Here, document DB and Apache Cassandra is my key spaces. This we did, no, document DB over here. That I have not done only as of now, but if you want to know, document DB is what AWS just copied MongoDB and created its own name, document DB. Key spaces is what Apache Cassandra AWS rebranded it as Amazon key spaces. That's it. Two of them. And then if
and
you want to, Redis is also there, no, Elasticache is there. Redis one.
yeah, Redis. Okay. Yeah, and one more question: how are we integrating this DynamoDB with any, let's say, any server?
You did
Uh,
it, no? In Terraform backend, remote backend, we did no DynamoDB table.
that we created it.
So it was integrated only, no, via the remote provisioners actually. Okay. That if you want to know, that is via means if you are asking Lambda, SDK, and what you need, DynamoDB. Here. This we did for EC2, right? In your class, import EC2, like that we did, no? Fine, I'll show you, no worries. EC2, Node.js, SDK. So if you remember, we did something like where EC2 equal to new AWS.EC2. If it is DynamoDB, go and search for DynamoDB. Nothing where DynamoDB equal to new AWS.DynamoDB done. And then whatever you want to do. This is one. And then if you go down, these are all the things. You want to create item, delete item, create table, describe table, whatever you want to do. That's it. Like over here, create table or this one. Go and just tell me the structure and that's it. DynamoDB.create table. Lambda basically what we did. Same thing.
Yes.
Done. Every SDK, if you know any one of them, rest is straightforward only. No, rest is only just copy paste of that. The only thing is that function you will have to go and see what it is. Done. Okay,
Okay.
fine. One of you other also had a question, I believe someone. Yeah,
Yeah,
Ravi.
yes. Is there any thumb rule to know which kind of database we need to use, either NoSQL or SQL?
Is there any what?
Thumb rule or how
No,
know
no,
what?
no, 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 nothing like that. Architects will decide. But if you ask me anything financial, I will go with SQL. Like you ask me, I will say anything financial, SQL. Rest it depends on you. You have a contract with Microsoft, go with SQL Server. Do not have a contract, you have a contract with Oracle, go with Oracle Server. You have a contract with MariaDB and Postgres are the free ones anyhow. Doesn't matter. So SQL is over there. NoSQL, generally, I will say you are talking about millions and millions of transactions, then go with Apache Cassandra. You say that in NoSQL, I want almost ACID properties, go with MongoDB. You say I want the fastest database in the world, in that case, go with Redis database. So it depends on the use case, but nothing like that actually, that only for this scenario I will use this.
Okay, thank you.
Fine. So we leave it over here then. I'll see you all tomorrow. Recording should be available in another 10 minutes. Tomorrow, 9:30 p.m. Goodbye.
Thank you.